Hello everyone. Today we are going to analyze this propped cantilever beam. In this beam, the support B sinks by 6 mm. EI is given as 9000 kN meter square. Now let us find the degree of static indeterminacy. In this beam, the number of unknown reactions and moments are 3. The available equilibrium equations are 2. The degree of static indeterminacy will be 3 minus 2. We will get 1. Since the support B sinks, we have to release RB. You can see that from the point B, I have released RB. So the point B becomes a free end. We know the formula to find RB. Delta minus delta L upon delta. Delta will be the settlement in the point B. We know that the support in the point B settles by 6 mm. We can divide that by 1000 so that we will get 0.006 meter. Since the settlement occurs downwards, it should be applied as negative. So delta is minus 0.006 meter. To find delta L and delta, we are going to use unit load method. To use that method, we have to make sections in this beam. In this beam, there is only one part, that is BA. So only one section is enough. You can see that I have made a section randomly here at a distance of x from the point B. Now let us make a table. In the table, first let us enter the members. We know that here there is only one member, that is BA. The origin of the section is the point B. The limit is 0 to 6. We are going to find the moments from the point B. In this case, we have to follow left-hand side rule. Clockwise will be negative and anti-clockwise will be positive. Let us find the moment M. The load 24 is acting in the clockwise direction, so that it will be negative, and the distance is x. We know that with the uniformly distributed load, we have to multiply the distance and the distance by 2. So for the moment M, we will get minus 12x square. Now we are going to find the moment small m. For that we have to remove all of the loads and to apply unit load in the direction of RB. The unit load is acting in the anti-clockwise direction, so that it will be positive, and the distance is x. 1 into x, we will get x. Now let us find delta L. The formula is integration of mm upon EI dx. For delta L, we will get minus 3888 upon EI. Now let us find delta. The formula is integration of m square upon EI dx. For delta, we will get 72 upon EI. In this equation, let us apply the values of delta L and delta. Negative into negative, it will become positive. For these two terms, we can take LCM. Then we can eliminate EI. The value of EI is given in the question as 9000. Finally, for RB, we will get 53.25 kilonewton. By applying the rule sigma V is equal to 0, we can find RA. Now let us take a moment about A and find MA. RB is acting in the anti-clockwise direction, so that it will be positive and the distance is 6. The uniformly distributed load is acting in the clockwise direction, so that it will be negative. We know that with the UDL we have to multiply the distance and then the distance by 2. Let us assume that MA is acting in the anti-clockwise direction, so that it will be positive. Finally, for MA, we will get a positive value. That means our assumption is correct. MA is acting in the anti-clockwise direction. Here you can see the shear force diagram. In this point, the shear force becomes 0. In this point, there will be the maximum positive bending moment. Let us make a section in this point and find the distance. You can see that in that point I have made a section at a distance of x from the point B. In this point the shear force is 0. Using that concept, we can find x. For the maximum positive bending moment, we will get 59.07. Here you can see the bending moment diagram. In this point, the bending moment becomes 0. This is the point of contraflexure. We can make a section in this point and to find the distance. You can see that I have made a section at a distance of x from the point B. In this section, the bending moment is 0. Using that concept, we can find x. Now we are going to end this session. Thank you for watching this video.